Hello guys, welcome back to my channel. My name is Larry, studying in Sri Venkateswara College of Engineering from the Department of CSE Data Science. Today we are going to see about the subject Mathematics for CSE stream. The course code of the subject is BCS 301. The title what we are going to see today is Basic Principles of Anova. Introduction to Anova. Anova stands for Analysis of Variance and is used to compare means across multiple groups. It helps determine if there are statistically significant differences between group means. ANOVA is widely used in various fields such as psychology, medicine, and agriculture. The analysis tool used in statistics that splits an observed aggregate variable found inside a data set into two parts, systematic factors and random factors. Purpose of ANOVA. The primary purpose of ANOVA is to test hypotheses about group differences. The assesses, it assesses the impact of one or more categorical independent variable on a continuous dependent variable. ANOVA can handle complex experimental designs with multiple factors and interactions. Types of ANOVA. The most common types of ANOVA are one-way ANOVA and two-way ANOVA. One-way ANOVA compares means of three or more independent groups based on one factor, whereas two-way ANOVA evaluates the effect of two independent variables and their interaction on dependent variables. Assumption of ANOVA. ANOVA assumes that the groups being compared are independent of each other. It also assumes that the data is normally distributed within each group. Homogeneity of variance is another key assumption, meaning the variance of the groups should be approximately equal. Null and alternative hypothesis. The null hypothesis in ANOVA states that all group means are equal. The alternative hypothesis suggests that at least one group mean is different from the others. Hypothesis testing in ANOVA is conducted using an F-static derived from the variance estimation. The difference between alternative hypothesis and null hypothesis. Alternative hypothesis is formulated in an affirmative form, whereas null hypothesis is a negative form. Assumes a specific relationship between variables, assumes that there is no relationship between the variables, implies that the outcome will be observed if one condition is met, implies that the outcome will not be observed if the condition is met. F-static and p-value. The F-static is a ratio of the variance between the group means to the variance within the groups. The higher F-static indicates a greater degree of difference among the group means. The p-value determines the significance of the result with a common threshold set at 0.05. Post hoc tests. If the ANOVA results are significant, post hoc tests are needed to determine which specific groups differ. Common post hoc tests includes Turkey's HSD, Bon Bonferroni and Skeffy's method. These tests help control for type 1 error while making multiple comparisons. Effect size in ANOVA. Effect size measures the strength of the relationship between the independent and dependent variables. Common effect size measures for ANOVA includes eta squared and mega squared. Understanding effect size provides additional context beyond just statistical significance. Limitations of ANOVA. ANOVA does not specify which groups are different if the null hypothesis is rejected. It is sensitive to violations of its assumptions, particularly normality and homogeneity of variance. ANOVA can only compare means but does not provide information on the direction of differences. Conclusion. ANOVA is a powerful statistical tool for comparing means across multiple groups. Understanding its principles, assumptions, and limitations is crucial for correct application. Proper interpretation of ANOVA results can lead to valuable insights in research and decision making. Thank you guys for watching this video.